All right, howdy. We're going to look at section 6.2, multiplying and dividing radicals. I'm going to try and do it without my calculator. I have a couple of charts that I'm going to use to assist me. I have my square free chart and my power chart, and those are going to help me to do these problems without having to get the TI-83 out. We're trying to not use that when we can. Not that it's bad to use it, but sorry, I can't write. And okay, not that it's bad to use a TI-83. It's just better if you look smarter and are able to use some of those tables and whatnot. You just look better. So I'm going to try to do those. Let me just shut up and go ahead and get into this lesson, shall I? I didn't just say shut up, did I? Goodness gracious. I apologize in advance. So the nth root of A times the nth root of B. And what I'm doing is I'm multiplying radicals, and this is just the general case. The index has to be the same. They're both n, and so you can just do A times B there. So that is the nth root of A times B. And if the index isn't the same, you just can't do it. And that's all there is to it. So let's look at a couple of simplifying problems. Simplify. The problem is the third root of 54 x to the fifth power. Okay, we had a problem kind of like this yesterday, except that everything went evenly yesterday. Okay, and these are not going evenly. You have 54 is not a perfect cube, and 5 doesn't divide by 3. So what I'm going to do is I'm going to break this up into a good radical, and then whatever's left over I'll put over here. Okay, now we have a chart that will help us with the 54, although we should, what's a perfect cube that will go into 54? So looking at the perfect cubes, and we can break this down pretty quickly. We're looking under the third power, and what's a number that 54 will divide by evenly? Well, most of these numbers are way too big, right? So I only need to look at the first couple, but 64 is already bigger than 54, so it's not going to divide. So 54 divided by 8, does that go evenly? No. I know that because of my multiplication facts. 8 times 6 is 48, and so on, and 8 times 7 is 56. So those don't work. 54 divided by 27, that does work. Okay, that's twice, right? Double 27, you get 40, no, 50, 54. 7 times, so double 7 is 14. So that's 27 times 2. And then I need to take care of the x. Let's see, 5 divided by 3 doesn't go evenly, but 3 divided by 3 does. Just need to note what I have left over here. So 27 x to the third. Everything will go evenly, but I had to keep this as well, just so it would be equal to this. 27 times 2 is 54. 3 plus 2 is 5. So for my final step, I'm going to actually evaluate, simplify everything inside the good radical. It's 3x. Okay, the third root of 27 is 3. 3 divided by 3 is 1. Times the third root of 2x squared. Just copy that one. Okay, let's try another problem that has another step at the beginning, but the rest of it will work just like this one here. So we have, let's see, 72, the square root of 72, x cubed y squared, and then 10xy cubed. Okay, the first thing I need to do is multiply them together. I'm going to use this property I stated at the beginning. So multiply, that is 720, x to the fourth, y to the fifth. Okay, now for the square root, I actually have a square free chart that will do this for me. Let's see, 720, let's get this over here. Where's 720? I don't know how well you can see that. Let's see, 720, oh, there it is. It's right there. So 720 is 144 times 5. 720 is 144 times 5. You could have done a factor tree of perfect squares to break that up. You could have used the table in your TI-83. There are different ways to get there, but this is what you need to get to at some point. We've kind of talked about those ways before. Moving on here, 4, that divides by 2 evenly. So x to the 4th, just put it all inside the good one. And y to the 5th power, well, 5 doesn't divide by 2, but 4 does. Remember, the index is 2, right? I keep saying divide by 2. That's because the index is 2. Okay, that leaves me with a y over there. So my last step, 12, let's see, that's going to be x squared, y squared. So the square root of 144 is 12. 4 divided by 2 is 2. The square root of 4 is also 2, but I'm dividing this by 2. 4 divided by 2 is 2. 4 divided by 2 is 2. And you're left with the square root of 5y at the end. So that is fully simplified. If I multiply those two radicals together, do all the simplification work, I get this for my answer. Okay, let's look at a couple more. Those were the multiplication examples. Let's do a couple of division examples. The first one will divide evenly, and that one's going to work out a little easier. So 18 x to the 5th over 2x to the 3rd. Square roots. And by division, of course, we mean a fraction, right? Fractions mean to divide. The division symbol looks like a fraction. So what does this equal? Well, so long as the indexes are the same, we can just reduce this. So 18 divided by 2 is 9. 5 minus 3 is 2. And look, now everything is a perfect square, right? The square root of 9 is 3. And 2 divided by 2 is 1. So it left me with 3x. I'm actually not going to put absolute values here. Okay, based on the fact that I was taking a square root back here of this odd exponent, well, x couldn't have been negative, because if x was negative, then the square root wouldn't work at all. So I'm not going from, I know there's a step in the middle here that's even, but I'm really going from odd to odd. I'm not going from even to odd, even though that's in the middle. That's just part of my work. So this is equivalent to that. X already had, just by writing this, I'm saying that x has to be positive already. So don't need absolute values there. It will be safe to put them there, but you don't need them. Next. So the square root of 7 over 2. Now, a radical isn't simplified if there's any square root in the denominator. Let me break this up first. Okay, so what I want is I'm going to multiply by something so that the denominator doesn't have a square root. The easiest thing to do is just multiply by the same thing, because any square root times itself just gives you that number. By definition, the square root of 2 times the square root of 2 is 2. Now, I can't just multiply by the square root of 2 with no consequence. I have to multiply by the numerator as well. This is similar to things we've done with complex numbers as well. You multiply the denominator by something, multiply the top by it as well, because this is really 1. I'm multiplying by 1. So multiplying across the top gives me the square root of 14, and I'm done. Those do not reduce. They look like they reduce, but they have different indices. That has an index of 2, and that has no index at all. So I can't reduce them. I can't do anything with them. Leave it alone. That's your answer. You're already correct. I hate it when a student is working on a quiz and they get to the right answer and then they continue working and they mess up something beyond that because they did too much work. It's terrible. It's terrible. All right? Let's do one more problem. Sorry, I'll get a hold of myself. Promise. So the third root of 7x. There we go. Whew. That was intense, huh? Over the third root. That's a wicked 3 there. Oh well. 5y squared. Now this one's going to involve a little more horsepower. I'm still going to multiply by something. And what I'm going to do here is I'm going to end up with the third root over here. And this is going to be a perfect cube, whatever's here. Okay? Well, I need to take 5 times something to give me a perfect cube here. And I can look at my chart and I can think about what perfect cube will 5 go into. So I'm looking at a perfect cube. And the first perfect cube that 5 will go into is 125. So that's what I want 5 to become, 125. And then for y, I need y to be y to the third power. So the first thing I'm going to do is set a goal for myself. This is what I want the denominator to become. That way, everything will be a perfect cube, and my denominator will be nice and have no radicals in it. Well, what do I need to do to get there? And then I'm going to copy that up top, and then multiply across the top to give me what the numerator will be here. So, what do I need? Well, 5 times 25 gives me 125. Okay, and y squared, 2 plus 1, gives me 3. So this is what I need to multiply by to make this happen. I'll copy this to the numerator. Okay, these have to be the same, just like these had to be the same. And let me see, 7 times 25, 7 quarters is $1.75. And for my last step, I'm going to finish the denominator just by writing it without the radicals. So 5y, 175xy, third root, and I'm done with that. So those were your notes on multiplying and dividing radicals. We're going to do a couple homework pages, one on multiplying, one on dividing.